Good morning. Today is September 11th. We're going to use the pages that you tore out on Monday, so go ahead and get those out. And you want to start on page 166. So I'm going to turn to 166. We're starting our new unit with figuring out when is a relation a function. So a relation is just a relationship between two quantities. A lot of times it's a word problem. A lot of times it's an X and Y. It's showing two things that have a relationship. And we're going to determine when is a relation a function. So for example, there is this word problem. Jonah is shipping 5 boxes for his uncle. Each box is the same size but a different weight. The cost to ship each box is shown. So see, there's different weights with different prices. Should Jonah expect that the cost to ship a 15-pound box will be a unique cost? So what do you think? When you ship a package, they measure how heavy it is, right? And then they give you the cost for shipping it. So is there a relationship between the weight of the box and the cost to ship a box? We could write, we're going to try to squeeze it in, so if you have big handwriting, try to write smaller. We're going to write every package with a different weight has a different cost. The cost is not increasing at a constant rate. Right? Because if you look, going from 8 pounds to 9 pounds, it went from 856 to 872, so that is about a 12-cent increase. But then when you go from 9 to 10 pounds, 872 to 901, that's more than 12 cents. So it's not increasing at a constant rate. So the question was, should Jonah expect that the cost to ship a 15-pound box will be a unique cost? Yeah, that makes sense, right? We are seeing that as the pounds go up, the cost is going up. So it makes sense that a 15-pound box will cost more than 14 pounds. I'm going to put LBS here. And if you need to pause the video at any point, go ahead and pause so you can get all the notes written down. Okay, I'm going to go look here. They organize the boxes on a dolly, right? That's what this is called. And then there's this little relationship. It's showing the input, which is the weight, right? Because if you input the weight, then it'll tell you the output, how much it costs to ship. Any set of ordered pairs is a relation. So anytime you have an X and a Y or two quantities, that's a relation. So that's already highlighted for you. You can also organize this information using, this is called an arrow diagram. So you draw these two ovals. This first oval, go ahead and label it input. That's where you start. Output is where you end up. So these arrows are showing for an 8-pound box, it's 856. For a 10-pound box, you're paying 901. Excuse me. Okay, what you're going to highlight here, or underline, a relation. So if you need to get your highlighter, you can pause it. A relation is a function when each input is assigned exactly one output. So that is a key part of today and tomorrow's lesson. For each input above, there's exactly one output. So this is a function. This relation is a function. So a relation is just when you have a pair, you have an X and a Y. But it becomes a function when each input has one output. So Jonah can expect that the cost to ship a 15-pound box, yes, it should be a unique cost. Okay, we're going to go down to the try it. Down here, Joe needs to advertise his company. He considers several brochures different brochures of different side lengths and areas. He presents the data as ordered pairs. So side length and area, that's the relation. So this is a relation, side length and area. So if a side length, I'm going to write this as input, and then I'm going to put side length, and then the output. So the side length is the input. Once you know the side length, then you know the area. We're going to fill out, complete the arrow diagram. So let's see, 2's already in there, right? 2, which goes to 20. So that one's done. Let's see, let's do the numbers that are already in here. 5 should go to 35. And check that one off. And then 9 should go to 27. So the arrows, oops, not really straight, goes there. So these two are missing. Okay, I'm going to put 4 in, goes to 24. And 8 in, goes to 24. Okay. Is the area of a brochure a function of the side length? So remember, a function is when each input has exactly one output. So the input of 2 goes to 20, 4 goes to 24, 5 goes to 35, 8 goes to 24, 9 goes to 27. So yes, you're going to write all of this down. The relation is a function, and that is because each input has one output. This question, there are 2 outputs of 24. Does this help you determine whether the relation is a function? So this arrow diagram, maybe you're wondering, how is this a function? Because 4 and 8 both go to 24. So let's organize it a different way. I'm going to write input and output. So I'm going to write the inputs of 2, which goes to 20, 4 and 24, 5 and 35, 8 and 24, squeezing in 9 and 27. So you can see here each input, right, is unique. And they each have an output. So the reason why this is a function is because each input has one unique output. Or let me rephrase that. Each input, let me rewrite that, make it a better explanation. So each input is unique to an output. Meaning all these inputs, right, has an output. So there's not an input that is used more than once. I'm going to flip the page to 167. Okay, so we're on example 2. Use tables to identify functions. Frank uses a table to record the ages and height of the 6 students he tutors. Is this relation a function? So this is a relation because it's showing a relationship between age and height. Our job is to determine if it is a function. So I'm going to use my highlighter. And the age is the input, because once you input the age, then you have the output of height. What are you noticing? So I notice, look, there are 2 9-year-olds. And then I also notice there are 2 8-year-olds in here, right? So the reason why this relation is not a function is because 2 9-year-olds have different heights, and 2 8-year-olds also have different heights. So we're going to summarize this. Not a function because x equals 9 has more than one output. I'm going to highlight that part in yellow to make it match. And then also because x equals 8 has more than one output. highlight that in pink to make it match. Okay, down here, Frank reverses the ordered pairs to show the heights and ages of the same 6 students, meaning he's now saying that the height is the input, X, and the age is the output. Is age a function of height? Explain. So looking at the inputs, that's what we care about, okay? Look at the inputs. Are there any numbers in here that are a problem, that are making this not a function? Just like here, right? We had double 9s, we had double 8s. Do we have any numbers that are being used again? Yes, the 54s. So because of that, this is not a function. Make sure you're writing this down, because X equals 54 height has more than one output. So I'll highlight that in yellow so it matches. Okay, I'm going to example 3. Heather and her parents are going to an art museum for the day. The parking garage near the museum charges the rate shown in the sign. Is the cost to park a function of time? So you can very quickly make this into a table to compare. So this side, the time is your input, right? Because when you park somewhere, the time happens first, and the output is how much you have to pay. That's your Y. So this is a relation, because it's showing a relationship between 2 quantities, the X and the Y, the time and the cost. But we want to know if it's a function. So to tell if it's a function, concentrate on the input side. So this is a function, because see how each input, the hours, has a different cost, right? So all of these inputs are unique, so yes, it is a function. If they stay at the museum for 6 hours, should they expect to pay more than $25? So if there was a 6, do you think they would pay more than 25? Yes, they should expect to pay more than 25, and that's because we notice as the cost increases as time increases, right? If you're going to park for 6 hours, you should expect to pay more than the 5 hours. Okay, Heather claims that she can tell exactly how long a family was at the museum by how much the family pays for parking. Is this correct? So she's saying, like, if they paid $10, she knows they parked for 2 hours. Is she correct? So she's not correct, because notice these are just whole hours, right? What happens if someone parked for 2.5 hours? They're still going to pay $15. But if they parked for 2 hours and 59 minutes, they're still paying $15. So no, because the parking increases based on 1 hour intervals, meaning only by the hour. The cost to park for, let's say, 2 hours and 30 minutes is the same as 2 hours and 59 minutes. Okay, we're going to flip another page, so if you need to pause to catch up, you should pause. Okay, I'm going to 168 now. Okay, up here were the key concepts. So this is like a snapshot of everything we've done. So a relation is a function if each input corresponds to exactly 1 output. You should highlight that. You can use, there's different ways that you can tell if it's a function or not. So this is the arrow diagram. You can use a table. And then personally, I'm not a fan of the arrow diagram. The arrow sometimes confuses students. So it's very easy to quickly just create a table to make it look like this, right? This is very clear. The arrows sometimes are confusing. So you could very quickly convert the arrow diagram to a table. So there's 1, 2, 3, 7, 8, 9, 5, 21, and 7, 14. This is all the same information, but it's a little bit more clear. So we're going to tell this relation, this one, the arrow diagram, or if you convert it to a table, this is a function, and that is because each input has one output. Oops, output. Right? Each input 1, 3, 8, 5, 7 is unique. But looking at this table, this one is not a function. What's the problem here? What number is causing this to not be a function? So it's not a function because you only look at the inputs. X equals the 2 has more than one output. So if in this table or this arrow diagram, if it had another 1 or another 3 or another 8 or another 5 or another 7, then we would say it's not a function. Okay, make sure you have all the notes. Your homework is continuing on here. It's pages 168 through 170, and you're finishing 4, 5, 6, 7, 8, 9, 10, 11, 12, and on the back 13. And then make sure you do the answer checker, okay? You always have to do the answer checker or the IXL. So make sure you're doing the computer component. And I'll see you tomorrow.